Okay, so previously in the playlist, I've mentioned intermolecular forces quite vaguely. In this video, I'm going to go through them in more depth. So the first type of intermolecular forces is van der Waals forces, and this is also called London forces and induced dipole-dipole forces. Okay, so how van der Waals forces works is we'd start with two molecules. Okay, so here we've got our two molecules of CO2, and I'm going to draw the electrons inside the bond. Okay, so the thing about the electrons in the bond is that they're always moving around that area. So at some point they'd be around here, at some point they'd be around here. Okay, they're just always wandering about. Now, by chance, at one point in time, the electrons could both be somewhere around on the right side. So that looks like this. Okay, and this is just by chance, right? For a split second. However, because of this, right, for a second, the molecule has a slight negative charge over here. Okay, because there's more electrons on this side. So it's slightly negative. And then the left side is slightly positive, right? Okay, so because this side is slightly negative and there's more electrons around this area, it repels the electrons in this molecule to the right side as well. So these electrons are repelled to somewhere around here now because of these electrons. These electrons repel these ones here, okay? So now these electrons are closer to the right side as well. So now this chlorine on the right is slightly negative as well. And the one on the left is slightly positive. And that slightly negative and that slightly positive are attracted to each other. And that force of attraction is called an intermolecular force. And that force of attraction is called a van der Waals force. Okay, so that's how van der Waals forces are formed. Now, you also need to be able to explain this in your exam, right? So this is like a typical mark scheme definition. So it happens when there is an uneven distribution of electrons in the molecule causing an instantaneous dipole, okay? So that basically just describes how by chance the electrons were on this side of the molecule and that caused a dipole, right? So this side became slightly negative and this side became slightly positive, okay? So that's what here to here describes. This induces a dipole to neighboring molecules, which leads to an attraction between slightly positive on one molecule and slightly negative on another. So that basically describes how these electrons and this negative charge repel the electrons in this bond so that the electrons go to the right side. And then there's an attraction between the slightly positive here and the slightly negative here. Okay, I've also left a picture of dominoes in this slide. And the reason for that is that if we think back to our diagram, this molecule over here gained a dipole, right? And because of that, this one gained a dipole, and that's going to cause a dipole on the molecules next to it, okay? So one of it causes another one to have a dipole, and so on, okay? And that's kind of similar to dominoes, how if one falls, then the next one falls, and then the next one, and it keeps causing a chain, okay? Okay, so our next type of intermolecular force is permanent dipole-dipole forces. Okay, so in this case, we'd have something like hydrogen chloride, which looks like this. Okay, and if we were to draw the electrons for these molecules, it would be somewhere in the right side, okay, closer to the right side. And the reason for this is that we know that chlorine's more electronegative than hydrogen, so it has a stronger pull on the electrons, right? So because of this, the chlorines are slightly negative and the hydrogens are slightly positive. Now, once again, we have a slight positive and a slight negative close to each other, and they're going to be attracted to each other. And this force of attraction is another intermolecular force that we call permanent dipole-dipole. Okay, so in your exam, if they ask about this, you can answer it by saying the difference in electronegativity leads to bond polarity. Okay, so that's talking about how one side is slightly more negative and one side slightly more positive because one of the atoms is more electronegative than the other. And in this case, the dipoles don't cancel each other out, right? Okay, so in a previous video, we talked about how a molecule can have no overall dipole because the charges cancel out, right? In this case, that doesn't happen because there's no symmetry. So basically, we do have an overall dipole, right? And since there is an overall dipole, there's an attraction between the slight positive of one and the slight negative of the other. So that's your mark scheme answer. Now, the last type of intermolecular force is hydrogen bonding. So this occurs with compounds that have nitrogen, oxygen, and fluorine, as well as hydrogen, okay? Okay, so I'm going to use ammonia as an example. So if we have two different molecules of ammonia, we have something like this. Alright, so if we draw the dipoles on both of these molecules, we get... Okay, so in these instances, when the element that's bonded to hydrogen is either nitrogen, oxygen, or fluorine, the difference in electronegativity is so much that the hydrogen becomes so positive that it can bond to the lone pairs on the electrons. Okay, but it's a very weak bond, right? So if I draw the electrons here, for example, it forms a weak bond with this lone pair of electrons, and this weak force of attraction between the slightly positive hydrogen and the negative electrons we call hydrogen bonding. Okay, so that's all three of our different intermolecular forces done. Okay, so for an exam question, the way you explain hydrogen bonding is by saying there's a large difference in electronegativity between hydrogen and oxygen. Now, obviously, in an exam question, it's either going to be oxygen, nitrogen, or fluorine, right? So instead of oxygen, you can just replace it with nitrogen or fluorine. And because of this, a slightly positive hydrogen and a slightly negative oxygen dipole is created, and an attraction is formed between the slightly positive hydrogen and a lone pair on the oxygen from another molecule. Okay, so just remember, it doesn't have to be O, it could be fluorine or it could be nitrogen as well, right? Now, in most cases, hydrogen bonding is stronger than permanent dipole-dipole, and permanent dipole is stronger than van der Waals, okay? Okay, so we can use this to explain the melting points of some simple molecular molecules. And this is really useful to think about in other topics such as alcohols and periodicity. Okay, just remember, this is a general rule, right? So there are some instances where like another factor has a bigger effect than one of these forces. Okay, so here's an exam question for you guys to try. Draw a diagram to show how one molecule of hydrogen peroxide interacts with one molecule of water. Include all lone pairs and partial charges in your diagram. Okay, so you guys probably don't know the structure of hydrogen peroxide, so I'm going to draw that for you guys so that you can use it. And it just looks like this. Okay, now have a go at answering the question. Alright, so they're asking us to show how one molecule of hydrogen peroxide interacts with one molecule of water, right? So our other molecule is going to be water, which looks like this. And I'm going to draw the slight negative and slight positive of all the molecules so that we get... And now I'm going to draw all the lone pairs on each of these. Now, you wouldn't actually know how to work out lone pairs, so I'm just going to show it for you guys, and it looks like this. Now, you may have already seen, but water has two lone pairs. And essentially, this slightly positive hydrogen is going to be attracted to the lone pair on this oxygen atom. So then we get intermolecular force looking like this. Now, I could, however, do something like the lone pair on this is attracted to the hydrogen here. Okay, so you could do something like that as well. That would be correct. This is just what I chose to do. Right, so while we're talking about hydrogen bonds, I'm just going to talk about why ice floats in water, and this can be explained because of hydrogen bonds. So normally, when you think about a solid in a liquid, the solid normally sinks in the liquid. So for example, if we have like a bunch of water, okay, and we threw a brick inside, the brick would sink all the way down to the bottom, right? However, whenever we have something like, you know, a cup of water, and we put in ice, the ice normally just floats right at the top, okay, like this diagram here. And the reason for this is that ice has more hydrogen bonds than water, okay? These bonds cause the molecule in ice to be further apart than in water. So we can see that in this diagram here. Molecules, as you can see, are further apart than in water. Okay, you can see that in water they're a lot closer to each other. And because of this, ice is less dense than water, which is why ice floats in water. Okay?